Hello everyone, and welcome to this video on quantum dimensions. Quantum physics can be a complex and often confusing subject, but today we're going to explore one aspect of it that might just blow your mind. First, let's start with the basics. What are dimensions? In our everyday lives, we're used to thinking in 3 dimensions: length, width, and height. But in physics, we often talk about 4 dimensions, adding time to the mix. This is known as space-time. But in quantum physics, there's another type of dimension we need to consider, and it's a bit more complicated than the ones we're used to. These are known as quantum dimensions, or more specifically, Hilbert space dimensions. To understand Hilbert space dimensions, we first need to talk about something called a Hilbert space. A Hilbert space is a mathematical concept that physicists use to describe the state of a quantum system. In simple terms, it's a way of representing all the possible states that a system can be in. You might be wondering what we mean by quantum system and quantum state. Essentially, a quantum system is anything that exists on a very small scale, like an atom or a subatomic particle. And a quantum state is a way of describing the properties of that system. For example, let's say we have an electron. Its quantum state would include things like its position, its momentum, and its spin. The electron can be in a superposition of these states. That is, it can exist in multiple states at once. And that's where Hilbert space dimensions come in. A Hilbert space dimension is a way of quantifying how many states a quantum system can be in. It's a bit like counting the number of dimensions in a physical space. But with Hilbert space, we're not talking about length, width, and height. We're talking about the number of possible states a system can exist in. Let's go back to our electron example. The quantum state of an electron can be described using 4 different quantum numbers. Each of these quantum numbers can take on certain values, and the combination of those values gives us the electron state. So, in this case, the Hilbert space dimension would be the total number of possible combinations of those quantum numbers. If we do the math, we find that the Hilbert space dimension for an electron is 2 by 2 by 2 by 2 equals 16. And there you have it, a brief explanation of quantum dimensions. While it may seem like a complex and abstract concept, understanding Hilbert space dimensions is crucial for understanding the behavior of quantum systems. Hopefully, this video has given you a glimpse into the fascinating world of quantum physics. Thanks for watching.